So today was our soil types experiment. So we were talking to kids about how you set up an experiment, and we were talking about what makes up soil, why is soil important, and there's 3 different particle sizes of sand, silt, and clay. And so kids were setting up 3 jars and pouring water through and seeing how the water drained.
We just sat down with the food corps people. They developed the lesson. They come to us with lesson ideas. We figure out how to combine them with our curriculum that we have here in Traverse City, which is the state standard curriculum and Common Core. And so we have ideas of what we need to be covering, and then they say, how can we connect this to what you're doing in your curriculum? Right now, we are connecting a lot of what they're teaching, like the soil experiment today connects to social studies and what we're learning about Michigan geography.
So today we're going to learn about different types of soil. What is soil important for? Yeah.
To help plants grow.
To help plants grow? Absolutely. What else?
It's important to our nature because it makes plants for all the animals and people that live around.
Yeah, everything starts at soil, right?
Today they were learning about different types of soils and what makes up different types of soils, and it seems like it's just the beginning of what they're teaching. They're going to be connecting it probably to what can grow in the different types of soils and what's a good soil to have in different regions. Michigan has a lot of really rich soils, and so it's really great when we're learning, geography of Michigan and which areas grow important things to our state.
So for 3rd grade, they talk about some geology, so a lot of the kids will mention things like sand breaks down from rocks. So we'll talk about that as well, and that's kind of the follow-up lesson to it as well. We talk about Michigan soils, and we have been talking about what grows in Michigan and what makes Michigan such an agriculturally diverse state. And so they begin to have an understanding on that and what grows in the garden as well based on soil types, and that's relative to the amount of, or the ratios of those 3 particle sizes, and so that's where we connect it as well. So soil is really, really important, and today we're going to do an experiment to learn about different types of soil. There are 3 types of soil. Anybody name a type that you think might be a type of soil? A type of something that you see on the ground? Maybe by a beach. What type of particles do you see by the beach? Yeah.
Sand?
Sand, exactly. So we have sand. That's a particle that can make up soil. Who's got another one? Something that maybe by a riverbed you might see this. Yeah.
By the beach, there's itsy bitsy rocks that is sand, and by the river there is mud.
Mud. And what could you use that's like mud, but you might use it in like a pottery class? What do you think?
Is it clay?
The word I was looking for pottery is clay, right? And there's one more that makes up our soil, and it's really hard, so I'm going to give it to you guys. It's called silt. And all of these are a part of soil. Remember, that's our science word. Instead of dirt, we're going to say soil today. All right, today we are going to do an experiment. Who can tell me what an experiment is? Yes, Emma.
It's something when scientists do to figure out something.
Yeah, something scientists do to figure out something, usually to answer a question, right?
We haven't had an experiment yet where they talked about the scientific method and, how do we hypothesize about what we're going to experiment about and then finding the results. So it'll be interesting to see what their final ideas are.
Can someone read that first sentence to me? That first part, after it says particle sizes experiment? Jazzy?
The soil is made up of organic matter mixed with 3 types of
Exactly, yeah.
particles, sand, silt, and clay. After
Sound it out, you got it. Conducting, exactly.
conducting this experiment, you will be able to draw.
I know there were a lot of words in here. You can sound that one out too. Conclusions.
Conclusions about each sample based on your observing.
Yeah, based on your observations. What's an observation? Who can give me an example of an observation? Yeah, Emma.
Like, if you're like looking at something really close and paying attention to it.
Yeah, like a scientist, right? You have to be really careful with what you're observing. And when you're doing an experiment, can you just do it however you want to do it?
No, you have to do it in an order. It's in like water measured, water pour, and all of that. You have to do it in the order it's telling you.
Mm-hmm, exactly. And what happens if you do something out of order? Does your experiment still work? Can you still trust your results that you get at the end of your experiment? If you don't follow the directions?
Then you can't do it.
No, right? Yeah.
It's like you have to follow the steps.
Exactly. You have to follow the steps. So we try to sort of reinforce the idea of the scientific method every time we do an experiment in class. And we have them use words like observation, hypothesis, go through steps and read through directions and talk about what it means to be doing an experiment versus just having fun at home playing with clay or, you know, if you'd play with silt or sand at home. And trying to get them to engage with it at sort of that scientific level rather than just a fun hands-on activity. It's hands-on, but it's also scientific, and so there's a process to it, and they have to understand the method, and using tools like a timer or stopwatch, measuring exact amounts, that sort of thing, also kind of bring in those other elements. And then the scientific method is something that they're continuously practicing throughout elementary school so that they really they're able to reinforce that, and by the time they go to middle school, they're able to name all the steps of the scientific process.
You want to read the jobs?
A, water measure. B, water pour. C, timekeeper. And D, recorder.
Okay, so everyone here, there's going to be 4 jobs. And so you're going to decide who at your table is going to have each job to do. So now we're going to read what those different jobs do. You want to read number 2?
Can we better name? To water measure, fill 1 tablespoon of water.
Mm-hmm. And we're going to change that to 2 tablespoons. So there's going to be little spoons, and you're going to do 1 tablespoon, and then you're going to do a second one. Number 3. Want to read number 3?
Mm-hmm. Water pour. Pour the tablespoons into soil sample number 1.
All right, so there's going to be little numbers on some jars. So you're going to find the number 1, and you're going to do that one first.
How about step number 4? Jazzy.
Timekeeper. Press start as soon as the water pour starts pouring, and press stop when the water is done dripping through.
All right, how about number 5?
Record the time on the table.
Okay, so you have a table in front of you, right? This is a table that we use in our science experiments. And so you're going to write, where do you think that recorder is going to write? And actually all of you are going to record on your page, but we're going to make sure there's at least one person that writes it down first so that everybody gets this information.
So are you going to do particle number 1, 2, and 3 all at the same time? No, you're going to do 1 at a time so that you can measure the time that each one takes. And then you'll press stop and the recorder will record. And then you'll move to number 2 and the same steps. And then you'll move to number 3 and do all the same steps.
So let's go over some of your results before we flip over the page, okay? All right, who can tell me which particle sample with your numbers took the longest to drain? Yeah,
Yep.
with the numbers. Number 3. Raise your hand if your group got the same results. Number 3 took the longest to drain. Okay, interesting. How about the shortest? Which one was the fastest with draining? River. Number 1. Raise your hand if you got the same result as River. If number 1 was the fastest one to drain. All right, so that group back there. Did anybody else get that number 1 was the fastest? Yep, you guys got number 1 was the fastest. Is there any water left on top of your sample? Was there anyone that had some water left on top?
Yes.
Which ones had water left on top? Over here.
All of them.
All of them? What else? Who had either all of them or a different response? Yep.
3 and 2.
3 and 2 had some water left on top over there. All of them over there. All right, so everybody got a little bit of different responses, and that's okay.
So the kids are often really surprised to see that water doesn't go through clay. And that's really important because if you have in your garden, if there's lots of clay, then you will see that it kind of forms pools and it doesn't get through to your plants as well. So they'll be able to really bring that knowledge into gardening, and they'll have something to reference and say, oh, that's why you don't want to have too heavy of clay in your garden soil, because I saw that the water just sits there and it's not going to get down to the roots.
I think it's also interesting for the kids to look at the particle sizes and to get a sense of what's big and what's small, and that actually the larger particles allow the most water to come through, because it's a little counterintuitive. And it's really interesting for them to actually see it, so that when they learn that sand has the largest particles, it makes more sense when they've actually seen it come through something right in front of them, rather than just hearing that as an abstract concept. So who can read that first sentence for me now that we answered our questions? Yes, Jess.
Sand's large particles help it drain water quickly. The water passes easily through the large pocket created by the space around a large particles as they stack against each other.
You know, it's interesting, when we were first asked to do food corps, when we were first asked to have a garden, the teachers just were like, we cannot fit one more thing into what we're doing in our curriculum. But I've seen so many benefits from, like I said, the kids willing to try new foods and enjoying snacks that are healthy for them, and having a better understanding of how we are connected to our area and we are connected to how food is created has been really exciting. So, so we make time for it, and it's worth it.